In this video, we'll be covering functions and types of graphs for additional mathematics 0606. So let's get started. Starting with functions. So a function is basically an expression or a rule that tells you a mathematical relationship between the independent variable and the dependent variable. So it's a rule that always assigns exactly one output to each input from its domain. So moving on to domain. Domain is a set of all the acceptable inputs. You can either restrict or define a domain, or it can also depend originally on the function. For example, if you have a linear equation y is equal to x, that would be valid for all real numbers. And if you had a function like square root of x, that would be valid for x is greater than equal to 0. Now, range is a set of all the possible outputs, which are your y values, and the range of the function depends on the domain, which makes sense since the outputs will depend on the set of inputs. So depending on how the domain maps onto the range, you can classify each function as one-to-one, many-to-one, or one-to-many. Now, classification of functions are also important since it's in your syllabus. So as you can see over here, I have a diagram that you can go through. So for one to many, that means for one value of x, there are multiple values of y. So as you can see, for example, for the x value 1, there are multiple values of y, 1 and 5. Then for many to many, this isn't really in your syllabus. I've just added this as extra information. It means for many or multiple values of x, there would be multiple values of y. Then moving on to one. This is the most simplest mapping, which is for one value of x, there's always going to be one unique value of y. So the best example for this is a linear function, where 4 would map to -1 and so on. Now, for many to one, it means for multiple values of x, there would be a single value of y. So the best example for this would be a parabola, or in other words, a quadratic, which is x squared. Because for multiple values of x, you would get the same y value. Now only an one-to-one function can have an inverse. So an inverse function basically undoes whatever operations are carried out in a given function, and it's a reflection across the y is equal to x line. Now domain and range also depends on the type of graph, which we'll cover later on. So please don't input the extremes of a domain into the function so that you can get the range. That usually only works for linear functions. Moving on to domain and range of composite functions. So as you can see, for example, take the composite function g f of x. Now, if you look over here, let's say these are all the values of x that you can have. Now, you're inputting all these values of x into your inner function, which is f of x, and then those values or outputs that you get from f of x will be your inputs for g f of x, because in g f of x would be your inner function, and the y values of f of x would go into g of x as an input. So you're basically taking x, you're inputting that into f of x, and whatever values you get for f of x would go into g of x. So for finding out the domain and range, first of all you check the inner function, which is f of x. Then you'd start with the domain of f. So your restriction is that, your first restriction for x is that you have to follow the domain of f of x. So basically all x that you're allowed to substitute into f of x. Now your step 2 is to check what happens to the input in g of x, since you're inputting f of x into it. Now for each x in that domain, you have to compute f of x and ask, is this value allowed in the domain of g of x? Now, if f of x gives values that are not allowed in g of x, you have to basically exclude those values from the domain. Now, step 3 is determining the domain of composite function. So, the domain of g of x is basically all x in the domain of f of x for which f of x lies in the domain of g. And your step 4 is determining the range of composite based on the domain of g of x, g of f of x. Now, moving on to the type of graphs that you can have for additional math. Starting with quadratic functions, it's essentially a parabola, and if there's no restriction, it would start from y is equal to 0 and it would go till infinity if you're talking about the y values, and for the x values, it would be from minus infinity to infinity. Uh, a parabola is generally in the form ax squared plus bx plus c. So whenever a or the coefficient of x squared is greater than 0, it's going to concave upwards, or all the points will be basically upwards. And then if a is less than 0, in that case the parabola would be concaving downwards. Now, moving on to linear functions, it's pretty simple. Its general form is y is equal to mx plus c, or y is equal to mx plus b, and these are basically straight lines. And you can see that I've mentioned all the range and domain for these type of functions over here. Now, moving on to reciprocal functions. We don't really talk about these type of functions formally, but I've noticed that for function related questions, they always give you questions based on these type of graphs. So for reciprocal functions, it would be in the form k upon x, and this models a inverse proportional relationship. So as you can see, there's an asymptote at x is equal to 0 and y is equal to 0. Then we have cubic functions, which are in this form. When a is greater than 0, it the function basically approaches positive infinity as x goes to the right. However, if a is less than 0, the opposite tends to happen. So uh, if a is basically negative, your biggest term is ax cube, and as your x value gets insanely large, that negative term would get really large as well. So the y values would actually start to decrease instead. So these are some common trends that you need to know about these functions while sketching them. Then you have simple rational functions, which are a bit similar to reciprocal functions over here. They, once again, in this case, there's a asymptote at x is equal to 0 and y is equal to 0, but as you can see, it's in the form ax plus b over cx plus d. So an asymptote is basically formed when the denominator over here is equal to 0. Like in this case, when x is 0, you would get an asymptote over here. Similarly, when the denominator, which is cx plus d, would be equal to 0, that's where the asymptote would form. And another asymptote is formed at a over c, y is equal to a over c, because your biggest terms in this case are ax and cx. And let's say that the x value gets really large, so you're going towards the right, so you can basically ignore b and d in this case. So you basically have y is equal to ax over cx, and you can cancel out x in both the cases, so you get y is equal to a over c. Now I know that for AdMath they don't really go a lot in depth about this, but this is just for your extra information so that you can solve these kind of questions faster. Then we have log and exponential functions. These are basically inverse functions of one another. An exponential graph would basically grow or decay rapidly, and it if you're talking about a function like y is equal to 2 raised to x, the asymptote would be at y is equal to 0, because no matter what the x value is, the function can never be negative or equal to 0. Now, logarithm is basically the inverse of it. So if there's an asymptote for the exponential at y is equal to 0, there would be an asymptote for the logarithm at x is equal to 0. So you can also use that trick to sketch your graphs faster. Now, if you want to know why the asymptote for a logarithm graph is at x is equal to 0, the logic is that since these two are basically inverse functions, one thing to keep in mind is that for logarithms, the argument, or basically whatever this x part is in the brackets for a log operation, it can never be equal to 0 or it can never be negative. So that's something important to keep in mind as well. So for your orange graph, you wouldn't accept any value that's negative or 0. That's why there's an asymptote at x is equal to 0 over here, and then the y value also slowly exponentially gets bigger as you go towards x is equal to 0. Now moving on to trig graphs, you have sin x, tan x and cos x. For sin x, it looks something like this. You need to know all the critical values for your sin x graph, which are at 0, 90, 180, 270, 360. Make sure you know that. If you know about transformations as well, that would really help you, because for AdMath, they usually give you graphs which have some sort of transformations. So we'll take a look at that as well in a while. Then for tan x, you have an asymptote at x is equal to 90 and then at x is equal to 270. So essentially your asymptote is at 90 and the period for the tan x graph is 180. So you would keep on adding 180 to the asymptote so that you get the next asymptote. Keep in mind that for a sin x and a cos x graph, the period is 360 degrees or 2 pi radians, and for tan x it's going to be 180 degrees or pi radians. So one thing that I've kind of highlighted is that you need to know how to label the x coordinate of an asymptote whenever you're asked to sketch a tan x graph. So please make sure you do that while giving the exam. Similarly for cos x, you have your critical values at 0, 90, 180, 270, 360. Make sure you remember all the values for your non-calculator paper. And this is just a snippet from the syllabus document. You need to know what amplitude means, what the period of a trig function is, and what's the relation between graphs and functions of trig. Then, for example, if you have y is equal to sin x and y is equal to 3 sin 2x, you need to know what happens. So, for example, over here, the amplitude would become 3, and then since you're multiplying x by a scale factor of 2, you would say that essentially the graph gets compressed by a scale factor of 2. So the trig graph would basically get smaller in this case. Now you need to know how to draw and use graphs of this. That's why knowing about transformations is really good. I won't really go through that because I'm assuming that by now most of you know what transformations are and how it works. If you don't, you can always go through that. And another thing is that fractions will always have a denominator of either 2, 3, 4, 6, or 8 for the fractions used uh, in your trig functions. So you can actually head over to Desmos and then you can basically sketch different type of graphs over here. So for example, if you have cos x graph, your basic cos x graph, you can play around with the values for a, b, and d, and you can see what happens overall. Now, the reason Desmos is really helpful is because it sort of helps you create an intuition about how the transform graph would look like. So I'll mention the link for this template for Desmos. Make sure that you check this out because this can help you actually perform better for your exams since you would have transformed graphs as well. So now let's just go through the syllabus document as a checklist. So you need to know what one-to-one functions are, what domain means, what range means, basically all the types of functions. You need to know that an inverse function is basically a function that undoes all the operations performed by the original function, which is f of x, and that it's a reflection across y is equal to x. You also need to know about composite functions. Then you need to know how to find the domain and range. So uh, as you can see, I already mentioned all those types of graphs that we could possibly have. So based on that, you can actually determine the range and domain. Um, then knowing the notation for functions is really important. Make sure you go through this as a checklist because Cambridge likes using various notations. Then you need to know why a given function does not have an inverse. So like I mentioned before, only a one-to-one function can have an inverse function. So if it's like a parabola function without any restriction, then you would say that it's not a one-to-one function. That's why. You need to know how to find the inverse. So if you have, for example, f of x is equal to 2x plus 3. So you would swap the x and y and then rearrange it in terms of x to find out the inverse function. So you would do x is equal to 2y plus 3, and that would be x minus 3 is equal to 2y, and y is equal to x minus 3 over 2, which would be your inverse function. Then you need to know how to use composite function and how to form them. Make sure you use the correct notation as well. And keep in mind that the order of functions for a composite function is really important. It's not necessary that f(g) of x might be the same as g(f) of x. Then if you're asked to show the relationship between a function and its inverse, make sure you show the line y is equal to x because it's a reflection across that. So as they mentioned over here, understand that each function is a reflection of the other in the line y is equal to x. So now let's practice this question that I've selected for functions. So they're told that the functions f and g are defined for x is greater than 0. So this is your domain by, and then you're given two functions f of x and g of x. And you're told that given that f of x exists, find the range of uh, the inverse function. Now, the inverse function, basically, the thing is, if you have, let's say, a normal function, an original function, and if it has a domain and it has a range, so when we talk about the inverse function, the domain of f of x would become the range of uh, the inverse function. So basically, the range of f of x would be the domain for uh, the inverse function, and the domain for f of x would be the range for f of minus x. So essentially you already told that the domain is x is greater than 0. Hence your range would be the domain of f of x, which is f of x is greater than 0. Now moving on, you have to show that the inverse function is in this form where p, q and r are integers. The two terms first. So you have y is equal to 2x squared minus 1 over 3x. So you can rewrite this as 2x squared over x, sorry, 3x minus 1 over 3x. And you can cancel the x's out, so you get 2. And then you can swap the x and y. So you get 2x is equal to 2y over 3 minus 1 over 3y. Now, first of all, just multiply everything by 3. So you get 3x is equal to 2y minus 1 by y. Now, you can multiply everything by y first. So 3xy is equal to 2y squared minus 1. You can write this as 2y squared minus 3xy minus 1 is equal to 0. And then you can actually use the quadratic formula over here, because it's essentially a quadratic formula in terms of y, right? You can do y is equal to uh, as you as you can recall, x is equal to minus b plus minus root of b squared minus 4ac over 2. So you can say y is equal to minus b, which is 3x, plus minus root of b squared, which is 9x squared, minus 4ac, which would be minus 4 times 2 times minus 1. So 4 times 2, which is 8, over 2a, which is going to be 4. Now obviously you can't have a plus minus for the function, so you have to look at the initial range for the given function, which is y is greater than 0. So you take the positive one, so that would be 3x plus 9x squared plus 8 under the root divided by 4. This would be your final answer. Now moving on to trig. So you can go through the syllabus document again. You need to know all of these, which are really important and which you should know about by now. Then everything else was from the presentation. I've mentioned that in the presentation, so I'll move on. Then you also need to know the given domain and how to solve trig equations when you're given these sort of equations. So moving on, the first thing that they told is to show that tan theta plus cot theta is equal to cosec theta sec theta. So first of all, rewrite everything in terms of sine and cos. Now we know that sec theta is the same as 1 over cos theta, and then cosec theta, that's just the same as 1 over sine theta. So you do sine theta over cos theta plus cos theta over sine theta is equal to 1 by sine theta cos theta. Now before moving on, just think about how you would solve it. The next thing you can do is make like terms, basically like fractions. So you would multiply sine theta and sine theta together, cos theta and cos theta together, so you would get sine squared theta plus cos squared theta, and recall that this is basically equal to 1. So you would get 1 over cosine theta sine theta is equal to 1 over cosine theta or sine theta times cosine theta. So it's basically the same thing. You can simplify and rewrite this as cosec theta sine sec theta, but you get the idea. Now moving on. The next part says and you have to solve the equation tan x theta is equal to 3 sin x theta for 0 to 360 degrees. So make sure that for these type of functions, sorry, these type of questions, you always make sure your calculator is in the right angle or radians. So first of all, let's just write this over here as sine theta over cosine theta equal to 3 sine theta. Now, the minute people see sine theta and sine theta in the on the first step, they would probably go like, "Hey, let's cancel these two uh, parts." But that's actually wrong, because for these type of questions, when you cancel two like factors, you're basically eliminating a possible answer. So that's why you would actually not cancel this. You'd actually hold on to this factor for now. Now, um, you're told to solve this equation. So you're told that x is greater than 0, x is less than 360. Now, first of all, let's think about the sine theta part first. Now, this is one entire term, and this is one entire term. When would these two terms be equal to each other? Obviously, one case could be when both of them are basically equal, as in both of them are 0. So, in the case where sine theta is equal to 0, both of the terms would be equal. But if you look at the domain, x is greater than 0, so that's not possible. So make a sine graph real quick. Now, at what other place can it be equal to 0? Over here. What is that equal to? 180 degrees. So that is your first value for theta. Now, if you want, you can cancel out sine theta and sine theta. So you get 1 by cos theta is equal to 3. Hence, cos theta is equal to 1 by 3. And we're told that theta is greater than 0 and less than 360. So just make a rough sketch of this. I prefer the graphical method. ASTC is not preferred by me. So if you just kind of estimate where 1/3 is, so you can find out the two angles. So I'll just use my calculator now. So cosine inverse of 1/3, that gives me 70.5 degrees. For trig functions and these trig equations, make sure your answers are to one decimal place as well. Now, if you look at this, due to symmetry, the next angle over here, since this one is basically 70.5, this entire oscillation would be 360 degrees. So this thing over here would be the same as 360 minus 70.5. So doing that gives you 289.5 degrees. So that's for part 1 and part A. Let me just bring this over here. Now you're told to solve this equation 2 cot squared y plus 3 cosec y is equal to 0 for 0 to 360. You can always rewrite it as degrees. There is no issue in that. Just make sure your final answer is in radians though. So just take a moment to write this in terms of sine and cosine. This is cos squared theta by sine squared theta plus 3 cosec. So cosec would be 1 by sine theta is equal to 0. Now you have the option to either you can make everything in terms of um, cos theta, or you can make everything in terms of sine theta. There is no issue in that, because recall that sine square theta plus cos square theta is equal to 1. So you can do either cos square theta is equal to 1 minus sine square theta, which is what I'll be doing, but you can also do sine square theta is equal to 1 minus cosine square theta. So you end up getting 2 times 1 minus sine square theta, and then let's just multiply everything, all the terms, by sine square theta, so that the denominator becomes 0. So when you multiply these two, it just becomes 1, because this and this cancels out. But if you're multiplying this with 3 over sine theta, you get plus 3 sine theta. Now simplifying this would give you minus 2 sine square theta plus 3 sine theta plus 2 is equal to 0. Now you have to recognize that this is actually a hidden quadratic, because it's in the form ax squared plus bx plus c is equal to 0, where essentially x is equal to sine theta. So you can just use your calculator right away and solve for x, which is sine theta in this case. Minus 2, 3 and 2 are the coefficients, and you get sine theta is equal to 2, or sine theta is equal to minus 1 over 2. Now since the sine theta graph is from minus 1 to 1, so the maximum possible value is 1, minimum is minus 1, you would reject this instantly because this is not valid. So just focus on this and keep in mind that the domain is from 0 to 2 pi. So let's make a graph for sine theta over here. I'll just label this sine theta from 0 to 360. Minus 1 over 2 would be approximately over here. So you get two values. So let's just do sine inverse of minus 1 over 2, which would be minus 330 degrees. So what should I do when I end up with a negative value? Now, you know that minus 1 over 2 is going to be this dashed line. So let's say you extend this line over here. Now, this over here is approximately, not approximately, it's exactly minus 130 degrees. Now, due to symmetry, since this point over here, so let me mark it, this point over here is exactly minus 30 degrees from your x-axis, essentially. Like this length over here would be minus 330 degrees, not the length but the x units. So due to symmetry, over here this would be 30 units ahead. So we can actually do, since we know that this is completely 180 degrees, you keeping in mind that this is in radians, you would do pi that plus, hold on, that plus basically pi over 6, which would give you 7 pi over 6. And you can always input that to confirm that it's valid, which it is. So that's your first value. Now moving on. Now the next value is over here. Now once again it's going to be 30 units behind the x-axis. You can think about it that way. So you would actually do 360 or 2 pi minus pi by 6, because 180 over 6 is 30. So that would be 2 pi minus pi over 6, which should be equal to 11 pi over 6. These are your two valid values for the given equation. Now moving on, you're told to solve the equation 3 sec 3x is equal to root of 3 cosec 3x for this given domain. So this is going to be in degrees, so just set your unit to degrees first of all on your calculator. Now sec 3x, that's the same as 3 upon cos 3x. Now that's equal to root of 3, and cosec is basically 1 over sine. So that would be sine 3x. Now that's your first step. Now notice how I can take sine 3x over here, and then I will end up with sine 3x over cosec 3x, which is the same as tan 3x. So let's do that. Sine 3x over cos 3x is equal to root 3 over 3. So that means tan 3x is equal to root 3 over 3. Now for these type of questions, there are quite a lot of ways to solve it. I use the method where we equate 3x to a new variable. So I'll show you my working for that. If any of you prefer that or like that, you can stick to that, but you're free to use whatever method you like. So first of all, since we are dealing with a tan 3x graph, right? The thing is, it would obviously have some sort of a new transformation. But what you can do is, you can sort of encode 3x to a new variable. So first of all, you start off by saying let 3x equal to z, for example. So you'd get tan z is equal to root 3 by 3. Now this z variable, which is encoded, is actually going to have the normal tan x graph. So it will be, for example, like this, and then you have your asymptote at 90 minus 90, right? But another thing is, you need to look at the domain. Now this domain is for x, but we're dealing with z, which is 3x. So you'd multiply the entire thing by 3 first of all. So you get minus 360 uh, is what x can 3x can be, uh, least, and then maximum it can be 360. So you get the new domain as z is greater than equal to minus 360 and less than equal to 360. So make a graph for this in the given domain. So this is obviously 90, this would be 180, and then this would stretch out over here, and that's kind of one. So this goes like this to 270 over here, and this would go till 360, so you can mark 360 over here. Similarly, do the same thing on the left hand side for the negative values. This is for 90, then this would be minus 80 over here, and then you get essentially minus 270 over here. So this is minus 270, and then this is 360. This is the entire valid graph. Let me just shift a bit to the right. Now they're asking you to find out the values of z. So this is, you can label this as tan z, which is encoded. This is, since it's encoded, in the end, once you find out all the values of z, you would actually uh, um, divide those values by 3 so that you get your actual values for x. So first of all, where exactly is root 3 by 3? So root 3 by 3 is approximately 0.5. So you can make a horizontal line around here. And let's say it's root 3 by 3. Now I'll just use all the points, blue points to highlight all the intersections. So you would have 4 valid intersections or 4 valid solutions to this. Now you make use of the rule for adding 180 or subtracting 180. First of all, find out your base angle. So do tan inverse of root 3 by 3. Tan inverse of root 3 by 3 would give me root 3 over 3. That gives me 30 degrees. Just double check whether it's in degrees. It is. Perfect. Now I'll just list all the solutions for tan z over here. So z is equal to either 30 degrees, then 30 degrees is over here. If you go ahead, this would be 180, right? Cos 3 by cos 3x is equal to root 3 by sin 3x. Sin 3x or cos 3x is root 3 by 3. So you have tan 3x is root 3 over 3. Okay, I don't think we did anything wrong till now. Just make sure you double check as well, because if you do mess up, it's going to be really hard to tell later on. So first of all, your base angle is 30 degrees. Then if you look over here, this point over here that I'm marking with red would be 180. Now this entire thing, the blue point would be 30 units ahead of 180. So you'd do 180 plus 30. 180 plus 30. Now let's go behind. So if you look over here, you have minus 90 over here for the asymptote. Then you have minus 270 as the asymptote, and then this point over here is 180, minus 180. It's quite difficult to tell, but yeah, this is minus 180. Then we can say that since this is minus 180 over here, this entire length, or you can think about it as the x coordinates, would be 30 units apart. So you would do minus 180 plus 30 to get the next value. minus 180 plus 30, because the blue point would be 30 units ahead of the red point, kind of like how we did over here. So that's your third point, and then over here this is minus 360 degrees, uh, right over here. So similarly you do minus 360 plus 30 degrees. Now this isn't the end of the answer, because notice how like I talked about it earlier, you divide all the values by 3. So you would actually get x is equal to 10 degrees, or it's equal to 180 plus 30 degrees. Answer divided by 3, which would be 70 degrees. Then you have 180, sorry, minus 180 plus 30 degrees, which would be minus 50 degrees. Then you have minus 330 over 3, so that's minus 110 degrees. So these are all the possible values in the given domain for x. Now the next part is to solve the equation 2 cos y plus pi over 3 times sine pi over y plus pi over 3 is equal to sine y plus pi over 3. So I will be sticking to the same logic I used over here. We'll basically equate the argument or this thing that's in the brackets to a new variable so that we basically encode it. So let's start off with that so that it makes a bit more sense. So let x equal to y plus pi over 3. So you get 2 cosine x times sine x is equal to sine x. Once again, please do not cancel out these two values right away, because you are going to lose in this case, because it's a sine x graph from 0 to 2 pi. You can potentially lose two solutions. So you would actually lose like around 2 marks, possibly 1 to 2 marks. So first of all you have this. Let's find out our new domain for x. So you do pi over 3, because you're adding pi, is less than equal to y plus pi over 3, which we can rewrite as x because that's what we defined x as, which is less than equal to 2 pi plus pi over 3. Alright, that's our new domain for the sine x graph, and sorry, for the equation. So we can start off by considering when sine x is basically equal to 0, because when that happens both the two sides would automatically equal to 0. The thing is, you cannot equate sine x to some other value, because the thing is cosine x also plays a role for the left hand side. So that's why apart from sine x being equal to 0, there isn't any other possible value that you could consider. So you have this. Now you have to try making a graph for this given domain. So first of all, let's make a normal sine x graph, right? Now pi over 3 is basically 180 over 3, which is going to be 60 degrees. Now we know that this is basically 90 degrees, right? Which is pi over 2. Now half of pi over 2, which is 45 degrees, would basically lie around here, right? So that's 45. It's going to be a bit greater than that, so kind of like over here. So you would actually extend your sine x graph to something like this. Now you can also do sine inverse of these two extremes if you want, if that just helps you out, but it's a bit time consuming, so I wouldn't really recommend that. So this is your graph. Now you have to obviously make the domain, you have to consider the domain as well. So pi over 3 would be kind of like over here. Now 2 pi plus pi over 3, you have considered it right over here. So for sin x is equal to 0, the only possible values can be this or this. Now that would be the same as 180 degrees and 360. So these are your two values for x first of all, and it is in radians. So 180 is basically pi, and then you have 2 pi. So you can do, if you take this over here, you know that y would be equal to x minus pi over 3. So pi minus pi over 3, and then 2 pi minus pi over 3, which would be equal to these two values. So calculating this would give you 2 pi over 3, and then you have essentially 6 minus 1, so that would be 5 pi over 3. These are your two values that you would get from sine x. Now uh, these are two values for y, veggies. So these are your two final values. Now you can just cancel out sine x because we already considered the possible values for that. So you get 2 cos x is equal to 1 because this would be 1, and then cosine x is equal to 1 over 2. So let's just write that over here. Cosine x is equal to 1 over 2. Let's just make a graph of cosine x. Now keep the domain in mind. It's from pi over 3 to 2 pi plus pi over 3. So once again, if I were to make this, it would be something around here. Now this point would be 90 over here, where the x-intercept. So half of that would be 45 around here. Now we're talking about 60. So clearly it would be something around here, although that's not accurate actually. So I think for this part it would be better to do cos inverse of the two extreme points in the domain. So cos inverse of pi over 3, and then cos inverse of 2 pi plus pi over 3. That would be a smart way to go about with this over here. So like over here. So if you do half, now you have to see whether near the extreme points would we consider the values, but one definite value is going to be this, which is this is 90, 180, 270. So this would be greater than 270. Apologies. That's 1 over 2. Okay, so that's a good sign. We're saying x is greater than equal to pi over 3. So that's a value you consider right away actually. So pi over 3, keep that in mind. Then cosine of 2 pi, 2 pi plus pi over 3, that would give you 1/2 as well. Okay. So over here we're getting these two valid values. Now we also have to check whether this red value is valid or not for cos x is equal to 2, half. Your base angle was basically this point over here. So this entire thing was pi over 3. Similarly, uh, since this is 360 basically, so from 360 to the red dot, that would be pi over 3 as well. So you actually have to do 2 pi minus pi over 3. Sorry. So you do 2 pi minus pi over 3 as well. So what does that give you? 2 pi minus pi over 3. That would give you 5 pi over 3. And okay. So this, then this, and this over here would be your three values that you get from the cosine graph. So x is equal to 5 pi over 3, or it's equal to pi 3, or it's equal to 2 pi plus pi over 3. Let's just see whether, oh, sorry. So notice how 2 pi plus pi over 3 won't be considered because over here it's clearly y is less than 2 pi. So keep that in mind as well. Make sure you double check with the domain always. It's going to be less, so you won't consider this. So these are the only two values to consider. So y would be 5 pi over 3 minus pi over 3, because like we got from over here, um, over here y is equal to x minus pi over 3, and then you have pi over 3 minus pi over 3. So this would give you the two values, which is 4 pi over 3 comma 0. And in total you found out these two values and this. So these four values would be the solution.